Hello everyone, I am Prabha working as Assistant Professor in Department of Chemistry at Katpam Academy of Higher Education. In last class we seen about classification of elements like S block, P block, D block and F block elements. Today the topic is periodic trends in properties of the elements. So what is the brief of the topic is, periodic table is fully filled with elements. That elements are from lithium to cesium, it is considered as a group, and lithium to fluorine, this type is considered as a period. Okay, so this group and period have some properties like atomic ionic radii and electron gain enthalpy and ionization enthalpy along with number of atoms and its nuclear charge. Okay, so first we see about what are the physical properties of the elements. Okay, physical properties. So normal physical properties are melting point, boiling point and color. These are all normal physical properties of that elements. Okay, so in periodicity or periodic trends influence properties are atomic radii, ionic radii and ionization enthalpy. Next, electron gain enthalpy and final electronegativity. Okay, so these 5 physical properties are well defined that periodic trends along with the elements. Okay, so first we see about atomic radii. So what is mean by atomic radii is the radii of the atom. Okay, the radii of the atom. So this atomic radii cannot be measured by practically at first. Okay, so what the method is to record the atomic radii means here first they are considered covalent radii. Why it is called as covalent radii means here the chlorine atom distance is measured. Okay, that distance is 198 picometer. So the distance of the atoms considered in the unit picometer. Okay, so here the chlorine to chlorine distance is 198 picometer and this bond is considered as a covalent one. Covalent one. That covalent means it is equal sharing of electrons. Okay, so comes from that covalent radii we consider the atomic radii because it is 2 chlorine atom. So the distance is divided by 2 means we getting single chlorine atoms radii, that is 99 picometer. This types only we can estimate the atomic radii of the elements. Okay, so first they consider covalent radii, secondly they applied it for metals. Okay, so that one is called as metallic radii. Here copper 2 Cu2 metals have a radius 256 picometer. So the copper radii is considered as 128 picometer. Okay, likewise here from covalent radii they are considered metallics and it termed as metallic radii. As such we come to the atom, the term is considered as a atomic radii. Okay, and after all this atomic radii are confirmed by X-rays and another spectroscopic techniques. Okay, so consider the atomic radii along the period. Okay, along the period it is increases with increases in the atomic number. Okay, Like lithium have atomic number 3 and beryllium 4, boron 5, carbon 6, nitrogen 7 and oxygen 8 and fluorine is 9, and its atomic radii is lithium have 152 and beryllium has 11 and boron has 88 and 77, and with increases in the atomic number, here decreases the atomic radii. Here what happens means two properties are influence this one. Okay, that one is number of electron and another one nuclear charge. Okay, here what it happens means number of electrons are filled with same valence shell. Okay, so the shell does not increases. So the electrons are increased in the same energy level and in the same cell. But in the nuclear charge from lithium to fluorine, lithium have low nuclear charge, but fluorine have high nuclear charge. There is no electron repulsion. There is another one is it have high electronegativity. Okay, due to that nuclear charge variation, the atomic radii are decreases along the period. Okay, and comes from the group top from the lithium to cesium, it is atomic radii should increases because the energy level, the number of electrons fill in the different elements. Likewise, now already we told that lithium has 2s1 valence electron and sodium has 3s1 valence electron, and potassium has 4s1, rubidium has 5s1 and cesium has 6s1 valence shells. Okay, here the energy levels are increases properly. So the number of electrons filled in the energy levels are vary, and also the nuclear charge are vary in the comes from lithium to cesium. So along the group the atomic radii increases, and along the period the atomic radii of the element should decreases due to this nuclear charge, and in the group it increases due to filling the number of electrons in the valence shell. Okay, this one is the atomic radii, and second one is ionic radii. So what is ionic radii means? If that element loses the electron or gaining the electron, it become a cation or it is become an anion. Like lithium, decreases one electron, it is form a lithium plus ion. Likewise, fluorine gain an electron and form an F minus. Okay, so this type of cation and anion should be formed, and there is we consider as the radii is considered as ionic radii. Okay, so here the ionic radii follows same aspects of atomic radii. Likewise, along the period the ionic radii should decreases, and along the group the ionic radii should increases, because here the plus ion cations have loses the electron and its size should be decreases. Here the some of the elements should accept the electron and form an anion. It should the size of the anion should increases. If the metals or non-metals, the electrons should be decreases, means that ionic radii should decrease. And third one, that is ionization enthalpy. That ionization enthalpy are two types. That one is first ionization enthalpy. What is meant by first ionization enthalpy means, here the X is considered as an atom or an element, and we put a charge, the one electron is emitted from that atom or an element. This energy is called first ionization energy, and it forms an ion from atom. Okay, and second ionization energy means we put ionized element and give a energy, and it loses another one electron and form another one charge, x2 plus charge. Okay, here consider as a second ionization energy. Okay, so most of the alkali metals have first ionization energy only have. In alkali earth metals, we consider the second ionization enthalpy. Okay, so what is the periodic trends? That means nuclear charge influence this ionization enthalpy means here we consider two rows of the elements. One is alkali metals and another one is noble gas series. All of us we know that this noble gas series are completely filled elements. Okay, so here their their ionization enthalpy are increases in the line. Okay, so here the helium, neon, argon, krypton, xenons ionization energies are very large because it have a complete pack of electron in their atomic structure. Okay, so here that one electron from that atom removed is complicated compared to this. Okay, so that's why the ionization enthalpy of the noble gases increases compared with all other elements. Okay, here comes to alkali metals. Here lithium, sodium, potassium, rubidium, cesium have lower ionization energy because it have only one electrons in their outermost electrons. So it is easily ionizable. So it only have minimum energy required to remove the electrons. So that's why this alkali metals have lower ionization energy. Okay, and comparing to that period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, the ionization enthalpy should increases. Here this beryllium and boron and nitrogen and oxygen, here what happens means, here beryllium's atomic number is 4. Okay, so it is have a completely filled electrons in their orbit, and boron has 5. So in 5 means in 2p atomic orbital, boron has one single electron. So compared to that beryllium, this boron have one unpaired electron and it is in outermost electron 2p. So it is easily removable. So compared to that beryllium, boron have lower ionization energy, and likewise here nitrogen and oxygen have a same valence orbits, that is 2p. Here nitrogen has 7 atomic number and oxygen have 8. Here what happens means nitrogen's valence shell is 2s2, 1s2, 2s2, 2p, that means 3. Okay, so this is for nitrogen atom. For oxygen atom, one electron is more than that, that is 1s2, 2s2 and 2p4 is for oxygen atom. Okay, here that 2p4 means that fourth electron present in the 2px orbit. Okay, here what happens means in p orbital the complete electron filling in that is 6. Okay, here that nitrogen have half filled state, and here oxygen have one anti-parallel electron in its atomic orbit. That's why nitrogen have high ionization enthalpy than that of oxygen, because here this antiparallel electron easily removable, and here this nitrogen half filled state is, it is stable state. So here the one electron from this half filled state removal is, here the nitrogen atom have an half filled state. It is highly compatible with this noble gas, because noble is stable configuration and this half filled state is almost stable configuration state. So here from the removal of one electron from this orbit is more difficult compared to that oxygen. Okay, that's why here the nitrogen's ionization enthalpy high than that of oxygen. Okay, here all of that the ionization enthalpy of all the noble gases are high as such. Okay, and compared to group from lithium to cesium, the ionization enthalpy should decreases. Why it should decreases means there is one key point, that is screening effect. The screening effect is effective that increases in the atomic number, because lithium has 2s1 and sodium has 3s1. Like that, lithium core and its electron filling is, lithium have 3, so 3 electrons are there. Here the lithium atom, and sodium, compared to sodium it is 11. Okay, so core and electron fill like this, 1s2, 2s2, 2p6, 6 electron is there, and again the another series 3s1. Okay, here the nuclear charge, here the center core has a nuclear positive charge and the electrons are around in that. So there is an interaction between this positive and negative charges, that is called nuclear attraction force. So nuclear attraction force. Okay, this nuclear attraction force coming from lithium to cesium, it should decreases, because that shielding effect of this electrons. Okay, this shielding effect also consider as a screening effect. What happens means this surrounding electrons are screen the outermost electron from the nucleus. Okay, that is called as screening effect. Due to this screening effect, the ionization enthalpy should be lesser, because it is easily removable. Okay, compare this lithium, it is nearly present to the core, but here sodium, this electron fairly present from the core. So this fair electron easily removed compared to nearest electron. That's why here ionization enthalpy should decreases along the group. Okay, this ionization enthalpy unit is kilojoule per mole. Okay. Today we see about how the periodic trends influence the physical properties of the elements. We can see about 3 topics. One is ionic radii and atomic radii, and third one is ionization enthalpy. In next class we see about electron gain enthalpy and electronegativity, and what are the periodic trends influence in that. Thank you.